Once the UI is launched, first we will be in the welcome page. On the top left corner, select the option PCB Setup. The PlacerBot pick and place machine needs PCB size information and component placement list or Centroid position file to proceed with pick and place. If you have Gerber files with you, it can be used as a visual aid. But the recommended approach is to use without Gerber option. If you wish to use Gerber file as a visual aid, then select the option I have a Gerber file for the PCB layer and the border outline. In the next step, enter the PCB parameters. Type in the PCB name. Select the thickness of the PCB. Select the side of the PCB you are assembling. Select the color of the PCB. Take out all the output Gerber files and component placement list in a USB stick and connect it to the USB port in front of the machine. Now load the Gerber file and the border outline from the USB stick. Select the top copper layer or front copper layer. Next load the board outline layer. Select Load Gerber for border and select the border outline layer file. Click Proceed once all the files are uploaded. Once uploaded, the preview of the Gerber file can be seen beside the PCB dialog. This is the orientation in which we have to place the actual PCB in the workspace. Once the Gerber file is uploaded, click the option Mark PCB position on the work area. The machine moves the camera to the bottom left corner of the PCB workspace. Now use the right click on the mouse and Move Here command to move the camera center marker to the approximate bottom left corner point of the PCB. Right-click, select Mark the bottom left corner in this page. Now the UI changes, and you will get two windows. One shows the Gerber file that we uploaded, and the other shows a camera feed of the actual PCB on the right side. We can use the Gerber view to easily navigate to the fiducial point. The camera moves close to the selected fiducial on the PCB. Move the marker to fiducial point by using right-click, Adjust Here option. After positioning the marker at the fiducial point, right-click and select Add Fiducial. A dialog window will now appear with coordinates of the fiducial point that we selected. Approximate values based on the Gerber image is populated there. Edit the fields and key in the exact coordinates of the fiducial obtained from any design software or any Gerber viewer. Continue the same for the remaining fiducial points. Zoom out and move the pointer to the next fiducial point on the PCB, and follow the exact same steps. Once all the parameters are given, our PCB will now appear as PCB1 in the dialog. Next we have to upload the components list or pick and place list. Please navigate to the Components page by clicking on the Components tab. The component placement file for the pick and place process can be uploaded on this page. We can verify and update the component's orientation if needed. To upload the component placement list, first select the format of the component placement list, or CPL file in short. The format of the CPL may vary, depending on the design software used. Common PCB designing softwares are directly supported, It can be selected from the drop-down list. Select the format according to the software used for designing your PCB. We recommend the users to pre-process the placement list to standard CSV format. Next, load the components placement list. Select the components placement file from the USB stick. Now the placement list appears in the table below. The table can now be used for navigation to the various component locations. The display shows the work area, overlaid with Gerber image and camera feed. The camera feed and Gerber image can be enabled or disabled using the radio buttons. With the linked radio button enabled, the component table can be used for navigating to components on the PCB. Check the linked option. Now if you select any component from the CPF file, the camera will go to that component. Check the same for multiple components to verify. On the left side, we see a table showing the parameters of the component that we selected. The blue image of the component represents its orientation. The dot shown on the image depicts its first pin. We can change the first pin of the component by cross-checking with its orientation on the actual PCB. You can change the position of the first pin if it is different from its actual orientation on the PCB. Once the correct orientation is set, select the option Create Reference or Update Reference. Check the same for ICs and update if there is any change. For ICs, the blue square box represents its orientation. The dot's position represents the reference pin position of the IC. As you can see on actual PCB, the orientation of the reference pin is at the bottom left corner, whereas on the image representation of the IC it is at the top left corner. Update the pin position. Once updated, verify the reference pin position. Click Update or Create Reference to apply the changes. With all the components position verified and corrected, we can do a test inspect procedure to confirm all updated positions are correct. Press Ctrl+W. Look for the option Test Inspect Run. Click OK to proceed with the test inspection.